so the curve C has equation y equal to 4x squared minus 3x over x squared plus 1. So this is an improper fraction. Verify that the equation of C may be written in the form y equal to minus half plus 3x minus 1 square over 2x squared plus 1. And also in the form y equal to this. Okay, so if they want you to verify, right, and if I'm doing that, right, I can't use the normal way anymore, where I use long divisions, or I use divide by x square. It doesn't work anymore, you know. So because of that, let's verify it in this way. Okay, so we just make use of the equation minus half plus 3x minus 1 square over 2 x squared plus 1. Then we multiply with x squared plus 1 for this fraction, up and down. And we want to show that we will get the curve C equation. So if that happens, then that means this is true. Okay, so we do like this, 3x minus 1 square over, okay, now they have the same denominator already. So I just combine them, minus x squared minus 1, yeah. Because as you can see here, I multiply with x squared plus 1 because these fractions already have x squared plus 1 and 2, but this one have 2 only. In order to have the same denominator, we need x squared plus 1 to multiply with 2 so that they have the same denominator. It is x squared plus 1 only. This is times. The front part is times. Yeah, yeah, yeah. Okay. Then after that, if I keep doing, then I will get 8x squared minus 8x squared minus 6x. So over 2 x squared plus 1. And then I get y equal to 4x squared minus 3x over x squared plus 1. Okay, so I get that. So this is verified. Verified backwards is much easier. So likewise for the other one, they give us y equal to 9 over 2 minus x plus 3 square to x squared plus 1. Okay, so we can just verify it by using the same way, where we multiply with x squared plus 1 up and down. Okay, then we will get 9 x squared plus 1 minus x plus 3 square over 2 x squared plus 1. And then you will get 9x squared plus 9 minus x squared minus 6x minus 9. Okay, then we simplify this. 9 minus 1, we get 8. Then minus 6x, x squared plus 1. 4x squared minus 3x over x squared plus 1. Okay, so verified backwards is worth 3 marks. So if you don't do backwards, I think the working will be much longer. Okay, so will be easier if you do it in that way. So I settled the first part already. Hence, show that, yeah. hence show that, now they use hence, hence show that your y is between minus half to 9/2. So meaning that you have to use your result, these two results, to use these two results to continue. Okay, I have to use these two results to continue and get this interval. You can't use the normal way, like this one you bring over, then you do quadratic equation and do b squared minus 4ac less than 0 and show that. We can't do that anymore. Okay, we are not allowed to use b squared minus 4ac because the word is hence show that. So we have to make use of this result and continue it. Okay, so let's see how. Okay, so you can see we have minus half over there, and then we have 9/2 here, which is related to this. So you just need to see what to do with these fractions, and hence you can get that at the end. Okay, we have to think of it in that way. Okay, so I think of a way where I can put it in this way. Now, first of all, when I look at y equal to minus half plus 3x minus 1 square over 2x squared plus 1. Okay, so what I realize is, that this is confirm positive, because there's a square there. This is also confirm positive because power 2 x squared plus 1 is confirm positive. This is also positive, and hence what we can say is our fraction here, is always positive. This fraction is always positive. Okay, so because of that, we can claim something like this. Since 3x minus 1 square over 2x squared plus 1 is always positive, then always positive can equal to 0 can equal to 0 when x is 1/3. When x is 1/3, then this fraction is 0. For other value is greater than 0. Okay, so you add minus half on both sides. Okay, we put minus half on both sides, then we can get y more than or equal to minus 1/2. We get this. So likewise, for the other one, we just use similar method. Y equal to 9/2 minus x plus 3 square over 2 x squared plus 1. We know that this whole fraction, because of the power 2 here and there, we can confirm that this whole fraction is always positive. Since x plus 3 square over 2x squared plus 1 is always more than or equal to 0, and then we can just work it out in this way. X plus 3 square, I multiply with negative first to get less than or equal to 0. When you multiply with negative, it will change sign. And then you add 9/2 on both sides. Then you get y less than or equal to 9/2. Okay, then combine these two results. And then we get y less than or equal to 9/2 and more than or equal to negative half. Okay, so we get to show it. Yeah. Now let's continue with the next part. They say without differentiating. Without differentiating, you want to find stationary point, we have to do differentiation. Now they say without differentiating, write down the coordinate of the turning points of C. So how to determine that? Imagine this result actually means something. This result. Okay, let's say I just draw out part of the graph. I draw part of the graph. Okay, so this is the x-axis, this is the y-axis. So y equal to 9 over 2, let's say here. Y equal to minus half, let's say here. First of all, we need to know this interval that we found here means your graph is just somewhere around these two lines. So these two lines, somewhere in between these two lines. There is no graph above this region. No graph there. I shade the region with no graph. No graph below of the region down there also. Meaning that the turning point should be somewhere at 9 over 2. Somewhere at 9 over 2. You should expect some maximum point reach here and come down afterwards. Maximum point, for example. Okay, so, and at the meantime, there is no graph below of y equal to minus half, meaning that the graph may go down and then reach minimum point and turn up. They won't go down anymore. So because of that information, we get the idea where maximum point is somewhere up there, minimum point is somewhere down here. So then we find the turning point in this way. The turning point. So we I write down the equation first. Let's say because they just give 2 marks. So I make use of this then. I make use of this to find the turning point. Y equal to so y y equal to 9 over 2 minus x plus 3 square over 2 x square plus 1. The other side I use y equal to minus half plus 3x minus 1 square over 2 x square plus 1. So it is convenient if I use this instead of the original given equation, which is this one. If I use this to solve, I think more works to do. Okay, so let's see how we do it. Okay, so I start from here, this side. The turning point, like what I explained, we should expect it to stay somewhere around the y equal to minus half. Okay, so I put it here. When y equal to minus half, so I can easily cancel off the minus half because I have minus half on both sides. Then after that I will get 0 equal to 3x minus 1 square over 2 x square plus 1. And then I can bring the denominator over. I get 3x minus 1 square equal to 0. And then I can get x already. 1 over 3. Okay, so the turning point is 1 over 3 and minus 1 over 2. So we should expect a turning point somewhere here. 1 over 3 minus 1 over 2, and confirm this is minimum because there is no graph below of it, right? So we can confirm that it is going to be a minimum point. And on this side, I purposely make use of this to find the turning point. The turning point is going to be a maximum point, as this is the highest part of the graph. They can't go more than that already. So let y equal to 9 over 2. So 9 over 2 minus, 9 over 2 equal to 9 over 2 minus this. Okay, then we solve the equation. We get x plus 3 square over 2 x square plus 1 equal to 0. Then x plus 3 square equal to 0. X equal to minus 3. So turning point is minus 3 and 9 over 2. Somewhere around here. Minus 3, 9 over 2. And confirm this is maximum point, as the graph cannot go more than that. So that will be the maximum point over there. And okay, let's continue with the questions. Let's see the question again. State the equation of the asymptote. This one I think you know, but I just quickly go through also, as I need that to sketch the graph. So you know they are same power. They are same power. So let's say state the equation of asymptote. I do it here. Y equal to 4x squared divided by x squared. 3x divided by x squared. X squared divided by x squared. 1 divided by x squared. So I'm finding the asymptote. I divide by x squared, the highest power. Then I get 4 minus 3 over x. 1 plus 1 over x squared. So when x approaches infinity, my y approaches 4 over 1, which is 4. So the asymptote is y equal to 4. Y equal to 4 is the asymptote. Okay, y equal to 4. Vertical asymptote, we don't have any, because as you can imagine, the denominator you can't get any x value. You can't factorize already the denominator. We always get vertical asymptote from the denominator, so we don't have. So in this case, this is the only asymptote, horizontal asymptote. Y equal to 4. Okay, so yeah. Let's continue. Sketch the graph of C stating the coordinate of the intersection with the coordinate axis and the asymptote. Okay, so to sketch the graph, we need to find out the x-intercept and the y-intercept also. So x-intercept first. X-intercept, we let y equal to 0. Find x. Okay, so 0 equal to 4x squared minus 3x over x squared plus 1. So I can bring the denominator over and end up with no more denominator. Then I factorize the x, 4x minus 3. So the x-intercept are 0 and 3 over 4. These are the x-intercept. Then I can find out the y-intercept also. The y-intercept will be easier. I just let x equal to 0. Then y is equal to 0 straight away. Try to imagine. Substitute 0 to the x here. Substitute 0, you end up with 0 for the y. Okay, so we get the necessary information ready. Now let's put it in the graph. So the graph will pass through 0, 0 from what we found. Pass through 0, 0. And then the other x-intercept is 3 over 4. So we should expect 3 over 4 somewhere over there. The graph should go like that. Okay, then we have y equal to 4. Y equal to 4 as the horizontal asymptote. So we know that y equal to 4 is somewhere in between, somewhere here. So we draw a vertical line. Sorry, we draw a horizontal line. Y equal to 4. Okay, so that is the horizontal asymptote. And now we just join up. We have to know how asymptote works here. Asymptote is where the graph will parallel with it when it is approaching infinity. Okay, when it is approaching infinity, the graph will parallel with the asymptote. Okay, so I should expect it to go up and then reach here and then come down again and parallel with the asymptote. And here, parallel with the asymptote straight away. Of course, to confirm on this, right, my suggestion, you key in the whole rational function. Okay, this thing, you key in the whole thing. Okay, so let's say I key in now. I key in the whole rational function in the calculator. So 4x squared minus 3x divided by x squared plus 1. Okay, I key in the whole rational function, right? Then I press calculate. Then you can confirm on this by trying with value of x that is very big. For example, you can try with x equal to 100. Okay, let's see. I try with 100. Make sure, okay, I try with 100, right? I get 3.97. So showing that it is below of the 4. Below of 4 when it is very big. So I want to confirm this side also. This side. This side is where x is negative infinity, you know. So I just try with, let's say, negative 100. I want to confirm my y is greater than 4. So when I try with negative 100, the y that I get is 4.03. 4.03 greater than 4. So meaning that this is correct. If you want to confirm, are they really pass through the asymptote somewhere around here? You may try with maybe negative 2. Okay, I just try to confirm. I put negative 2 to see whether they are very close to 4. 4.4. Maybe I try negative 1.5. Negative 1.5. Yeah, very close to 4 already. Okay, I try negative 1. 3.5. Yeah. So meaning that it passes through 4 somewhere around negative 1 point something, no? Negative 1 point something that pass through 4. So meaning that this graph is going to be like this.